Good day, my dear students. This is the video discussion for module number 12, lesson titled Computing Probabilities Under Standard Normal Curve. Lesson objectives: at the end of this module, you should be able to compute probabilities and percentage areas under standard normal table, and solve problems that involves probabilities under normal curve. Productivity tip: think well, clear your mind, recall some probability concepts from your high school lessons. Check if you have the attached tables of Z values in this module. So the table of Z values can be found at the last pages of your module. That is two tables, one for negative and one for positive. Normal distribution, it is a probability function that describes how the values of a variable are distributed. It is a symmetric distribution where most of the observations cluster around the central peak, and the probabilities for the values further away from the mean taper off equally in both directions. For practical purpose, normal distribution is good enough to represent the distribution of continuous variable. So if we still remember the difference between the two types of variable, we have the discrete and the continuous. When you say discrete variable, those are the variables that have exact numbers. It is a whole. So example of discrete variable is the number of students in a classroom. So it is discrete because number of students pertains to humans, and wala namang kalahating tao. So when you count people, it's 1, 2, 3, 4, 5. It's exact. And when we say continuous variable, those are variables that can be expressed through decimals, like the height, weight, blood pressure, food intake, and many more. So can be expressed in decimal, hindi siya exacto. Hindi siya exact. Like the height, it can be 156.5 centimeters, 5.66 feet. Another is the temperature, 106.5 degrees Celsius, 38.7 degrees Celsius. So those are example of continuous variable. And in this module, you will learn to compute probabilities and percentages or percentage areas under standard normal table. Then shade the area under the normal curve and solve problems that involves probabilities under normal curve. So this is the Z table that can be found at the last pages of your module. This one is the cumulative probabilities for negative Z values, and this is the cumulative probabilities for positive Z values. Now, this is the standard normal curve. I drew this one during our discussion last Wednesday. This is the standard normal curve. We say that data is normally distributed. The normal distribution has mean is equal to the median and it's equal to the mode. So equal yung tatlong yan. And the symmetry about the center is 1. And 50% values less than the mean. Diba? Diba si mean is yung nasa may gitna. And 50% greater than the mean. So this is normal distributed if the mean, median, and mode are all equal. And nandun siya sa pinaka-peak, pinakamataas na part ng curve. Okay, so at the middle part or the peak of the curve. And this is a symmetry, 50%, 50% symmetrical. So 50% that is equal to 0.5 and another 0.5 that is equal to 1. And this is the standardized normal distribution. There are cases na ang given is the normal value or the x. So you need to convert it into a standardized value. So for the formula, we have the z is equal to the normal value minus mean divided by the standard deviation. So in doing that, that is called standardizing. So this is a normal distribution. Normal distribution, okay, same as with the standard normal distribution, the pick up the curve is at the middle part. And this is the average or the mean. But the number line below or at the bottom is a normal value, non 950, 970, 990, 1010, 1030, 1050, and 1070. So it can be convert into standardized form. That's 0, 1, 2, 3, and then 0, -1, -2, -3. So looking at this one, so para siyang si Cartesian coordinate plane, the middle part is the 0, which is the mean or the average, and then one standard deviation. So 1, tapos another plus 1, that's 2 plus 1 plus 3. And that's positive infinity. So the right part is the positive infinity. And then sa left part, okay, so -1, -2, -3, that's negative infinity. So that's the difference between the two. So we can take any normal distribution. Okay, so if it's a normal value ang given, you need to convert it into a standardized. So using this formula. So what's the difference between a normal distribution and a standard normal distribution? So they have the same curve, the bell curve, but in a normal distribution, it is determined by two parameters, the mean and the variance. And a normal distribution with a mean of 0 and a standard deviation of 1, that is called a standard normal distribution. So the normal distribution is a continuous probability distribution and several implications are the total area under the normal curve is equal to 1. So sabi ko nga that is symmetrical. So same ang measure to the left and the right part. That's 50%, 50-50. So 50% that is equal to 0.5. So 0.5, then 0.5 that is equal to 1. The probability that a normal random variable equals any particular value is 0. And the probability that x is greater than a equals the area under the normal curve bounded by a and plus infinity, as indicated by the non-shaded area in the figure. And the probability that x is less than a equals the area under the normal curve bounded by a and minus infinity. Additionally, every normal curve, regardless of its mean or standard deviation, conforms to the following rule. So this rule is called the empirical rule. That is 68, 95, 99.7. So for 68%, about 68% of the area under the curve falls within one standard deviation of the mean. About 95% of the area under the normal curve or the curve falls within two standard deviations of the mean. And about 99.7% of the area under the curve falls within three standard deviations of the mean. So this is known as the empirical rule or the 68, 95, 99.7. Clearly, given a normal distribution, most outcomes will be within three standard deviations of the mean. Now, to find the probability associated with a normal random variable, you can use a graphing calculator an online normal distribution calculator. I-type nyo lang sa Google, normal distribution calculator or a normal distribution table also. And in the example, we illustrate the use of StatTrek's normal distribution calculator. You can actually type this one in Google, normal distribution, StatTrek's normal distribution calculator, and it will appear. And then using that, you just need to type the z-scores, the condition, and then if it's greater than or less than, and then the standard deviation and the mean. This is a free tool available on site. So in the next lesson, we demonstrate the use of normal distribution tables. So this time, gagamitin natin yung table. So the standard normal table, or tinatawag din siyang z-score table, is used to calculate the area under the normal curve. So we will use the z-score table. In a z-score table found in the last pages of this module, so the leftmost column or yung pinaka-first na yung column is yung patayon. The first na nasa left column is it tells you how many standard deviations above the mean to one decimal place. So for example, it's 1.25. So see, the first decimal place is 2 kasi 1.2. So you look for 1.2 on the first column at the left. And then at the top row of the table, it gives you the second decimal place. For example, that's 1.25. So 1.2 at the leftmost column, first leftmost column, and then the 0.5, the second decimal place, hanapin mo siya sa top row. And then kung ano yung the intersection or yung tapat nung dalawang yun, the column and the row, that is the probability or the area. And these are the steps in calculating probabilities under the normal curve. Number one, translate the problem into the following. So this can be, these are three, those are the three. First is the probability that it is greater than A, and the probability that Z is greater than A, and the probability between A and B. Pag less than, that's to the left. Pag greater than, to the right. Now, the second is draw a picture of the normal curve and then shade in the area of the given probability P on the picture. This will help you to visualize the problem. So just draw the normal curve. Okay, so basta yung peak of the curve is at the middle, and then yung shade mong part will depend on the given. When it says to the left of the z-score, so you shade the left part. And then if to the right, you shade the right part. And if it's in between, so you plot the two numbers, thus you shade the middle part, the middle between those two z-scores. And number three, standardize A and or B to a z-score using the z formula if it's not yet standardized. If the given is a normal value, convert it into the standardized form using these z formula. And then number four, after converting it into a z-score, you look up on the z-score on the z table and find its corresponding probability. So let us now solve for the area under the normal curve. Remember that the process where we are using in reading, the area's value always starts from left to right. So in reading the table, we will start from left to right. So your first column and then the top row. So let's have this one. Okay, so for case number one, let's find the probability that Z is less than A. And pag sinabing less than, that is to the left. Now, determine the area of under the standard normal curve to the left of Z is equal to negative 1.06. So using the Z distribution table, go down first to the left column, the negative Z scores, and label to Z to negative 1.0. That's the first decimal place, point 0. So let's look for negative 1.0 at the negative distribution table. And then hanapin natin at the top row si 0.06. So this one, using this one, i-zoom natin konti. Yan. Okay, so negative 1.0, doon tayo sa left column. First column, negative 1.06. Ito, negative 1.0. And then the second decimal place is 6. So 0.06. Ito, si 0.06. And then pagdapatin natin silang dalawa. And then this one. Okay, so ito yung area. Okay, so that is 0.1446. Okay, so the answer, then we can write it like this one. It can be written as, since to the left, we'll use the symbol less than. So the probability that Z is less than negative 1.06, and that is equal to 0.1446. Now we can now what? Let's now draw the normal curve. So draw the picture of the normal curve. Let's use this. So we are looking for the area to the left. So to the left of Z is equal to 1.06. And see, negative 1.06 can be found at the left part. And negative 1, hindi siya sakto kay negative 1. So i-adjust natin konti. Negative 1.06. Okay, so tansyahin na lang natin. Sorry, ang hirap mag-go. Let's say that's a straight line. And then what we're going to do is shave the left to the left. So, i-shave nyo lang yung left part. Okay, so just shave this one. Shaved. Medyo mahirap mag-shave. Okay, so this is how you draw the normal curve for the area to the left of Z is equal to negative 1.06. So let's have the case number 2. So the probability that Z is greater than A. Determine the area under the normal curve to the right of z is equal to 0.71. If the case number one, that's to the left or less than, now it's to the right. So pag to the right, greater than A. And 0.71. This is a positive, so ang gagamitin nating distribution table is the negative. This one. The positive pala, sorry. Kanina is negative, now is positive. And that is 0.71. And the first decimal point is 0.7. 0.7. So let's look for 0.7 in this column. 0.7. Ito siya, si 0.7. And then, the second decimal place is 1. And that is to 0.01. Okay, so hanapin natin yung nagtapat silang dalawa, their intersection. And then this one. So we have 0.7611. That is the area. So we have, so the answer, since pag to the right yung hinahanap, since the total area of the curve is 1, then 0 to 0.71, we need to subtract 1. Now, the probability that z is greater than x is equal to 1 minus the probability that z is greater than x. So, yung nakuha nating area of 0.71, which is 0.7611, mag-minus tayo ng, i-minus natin siya sa 1 kasi that's the total area of the curve. And that is 1 minus 0.7611, and that is equal to 0.2389. Thus, the area to the right of z is equal to 0.71 is 0.2389. So, ganun kapag to the right, so subtract nyo yung makukuha ninyong area sa 1, which is the total area of the curve. And to graph, let's draw the normal curve. So we are looking for the area under the normal curve to the right of 0.71. And si 0.71 can be found in the number line between 0 and 1. And medyo malapit siya kay 0. Okay, so 0.71. Malapit siya kay 1 pala kasi 1 and then 0.71. So let's say nandito siya sa part na, sorry, banking. Here, sabi natin na dyan siya sa part na yan. And then, it's to the right. So, we shade the right part. Okay, so dito tayo mag-shade. Okay, so just imagine straight na lang and maayos yung shading. Okay, so this is the area to the right of z is equal to 0.71. So you see the difference? And now, after the case 1 and case 2, to the left and then to the right, now we proceed in between naman. The probability between A and B. So determine the area under the standard curve between Z is equal to 0.08 and Z is equal to 1.96. So let's find first Z is equal to 0.08. So using the distribution table, 0.0, okay, and then the second decimal place is 8. So 0.08. 0.0 and then the second decimal place is 8. Ito siya. So, yung tapat nilang dalawa, ayan, and then this one. So, that is 0.5319. That's for 0.08. And then the area to the left of Z is equal to 1.96. So that's positive again. So ang gagamitin natin is this one, the positive Z values. Negative, that is positive 1.96. So 1.9. The first decimal place is 0.9. So 1.9. Ito si 1.9. And then, dun tayo sa taas, 0.6. Ito si 0.6. Okay, so 1.9 and then 0.6. Okay, so we have 0.9750. So the area to the left of Z is equal to 1.96 is 0.9750. Now, if we are looking for the area between, so between yung hinahanap, so we're going to subtract the higher value or the bigger area to the smaller area. Our bigger area is, yung mas malaking area natin is 1.96 and then the smaller area is 0.08. We're into 0.08 is 0.5319 and then the area to the left of 1.96 is 0.9750. So that's 0.9750 minus 0.5319. Okay, so i-subtract nyo lang yung dalawa, the smaller, the bigger area minus the smaller area. So this one. Okay, so we have 0.4431. Therefore, the area between 0.08 and 1.96 is 0.4431. Now let's let's draw the normal curve for the area between 0.08 and 1.96. And 0.08 is between 0 and 1. So medyo malapit siya kay 0 since 0.08. So tansyahin natin. 0.08, dito siya between 0 and 1, and dito siya sabihin natin. So let's say this here. Just imagine this is a straight line. Here, mag-draw. Imagine nyo na lang straight line yan. And then, 1.96. That's between 1 and 2. Nasa pagitan siya ni 1 and 2. And medyo malapit siya kay 2 kasi 0.4 na lang. That is equal to 2 na. So, let's say it's here. And then, saan yung shade natin? We shade the area between. So, sa pagitan nilang dalawa. So, doon tayo mag-shade sa pagitan nila, which is sa gitna. Pag na-shade kayo, huwag na lang lagpas-lagpas. Hirap i-control yung mouse. I'm trying my best. Okay, so this is the area. This is the normal curve for the area between 0.08 and then 1.96. Now, for the last example, kanina sabi ko, it can be possible that the given is normal value. Hindi siya naka-standardize parang to na ang given is 0.08 and 1.96. What if naka-100 siya? So, for the task number 1 in your module, may sagot naman siya actually dyan, but let's discuss. Read and understand the first problem, then proceed to answer the second problem. By applying the same process, standardizing the score and solving the area under the normal curve. So this example, we will now use the formula in standardizing or the standardized form using the formula z is equal to the normal value minus the mean divided by the standard deviation. So the question is, the problem is Sir Jerome has 184 students in his college mathematics lecture class. So the scores on the midterm exam are normally distributed with a mean of 72.3 and a standard deviation of 8.9. How many students in the class can be expected to receive a score between 82 and 90? So the condition says between 82 and 90. And that's the normal value that is given. Yan yung gagamitin nating value ni x. Since it is between, so we will find the area for 82 and 90. Ang gagamitin natin dyan is yung parang si case number 3. I-apply natin yung case number 3. But first, we need to get the standardized form of the normal value. And looking at the given problem, so the given are n is equal to 184. That's for population kasi there are 184 students. And the mean, okay, so mean that's for population mean, yung symbol na yan. And that is equal to 72.3 and the standard deviation is equal to 8.9. It is between 82 and 90. So let's solve. So the values are not in standard z-score form, thus you need to standardize it. Now use the formula to standardize the z-score. So let's indicate na si 82, that's for the z of A, and then si 90, that's for the z of B. And z is equal to the value minus mean divided by the standard deviation, or z is equal to x minus mean divided by standard deviation. For the first one, for the letter A, we have 82. So 82 minus the mean was 72.3 divided by 8.9, that is equal to 1.09. And for the value, which is 90, that is 90 minus 72.3. and divided by 8.9, that is equal to 1.99. So yun ay standardized form ni 82 and 90. So now we will look for the error between 1.09 and 1.99. So looking at the distribution table, mag-input tayo ng table. Okay, so 1.09. Positive naman sila parehas. So we will use the positive value, z values. Now 1.09, so at the left column we have 1.0, this one. And then the second decimal place is 9. Ayun, so 0.09. And then 1.0, tapos 0.9. So ito yung intersection nila, and that is 0.8621. And then for 1.99, 1.99, so positive din siya. So the first is 1.9. Ito, si 1.9. And then, second decimal place is 9. So dun tayo kay 0.09. And then, so, yung tapat nilang dalawa, that is 0.9767. Ayan. And then, applying the case number, what we did in case number 3, we will subtract the bigger area to the smaller area. And the bigger area is 0.9767 minus 0.8621. That is equal to 0.1146. Okay, so this is the area between A and B, or between 1.09 and 1.99. Now, to solve for the number of students, kasi ang hinahanap sa problem is the number of students daw that are expected to get a grade between 82 and 90. Let's say that n is equal to area times n, wherein the area, ito yung na-solve natin, that's 0.1146 times, yung multiply natin by n, or the population, which is 184. 184 students. And that is equal to approximately equal to 21 students. Okay, so that's for computing probabilities under the standard normal curve.